Math guy, hello. Congrats on the first. Okay. Um. Oops. Just a teensy bit louder. Okay. So someone posted this question in my Discord. Oh, 1 second. Frickin' Logitech. Now we're good. Okay. Um, Someone posted this question in my Discord and said they got these answers, and so I thought we'd start the stream by checking them out. That's not the best formatting. Why would? Why? That's weird. I guess it's supposed to be an image, but it didn't render right. They say it right there though. Um, oh, I get it. That's like the alt text for the image. Haha. Hey Rex. So we have an exponential function shifted up by 2. Uh, let's just call it that. Why not? We don't have to be that exact. I love that emote. Hey Lucas. Horizontal line y equals 5 is going to be somewhere above it. So you got 59% on their math test. Was it you? Okay, and then we're also bounded by the y-axis. So we're looking, for part A, we're looking for the area of that region there. So then for part A, we're gonna do the integral from 0. Oh, that intersection point is probably not, well, it's something with ln. Hey, Fembucks. Half e to the x plus 2. We're assuming it's something with ln. 6 equals e to the x, I presume. Yeah. So x is ln 6. So 0 to ln of 6 of upper function 5 minus lower function, parentheses. Then whatever we get from here should theoretically be our answer. Come down here. 3x minus a half e to the x, 0 to ln 6. So we get 3 ln 6 moinish. 3 minus 0 minus 1/2. So 3 ln 6 minus 5 over 2. Okay, so I agree with their answer for part A. Oh yeah, I didn't put that together. So you literally just like missed the passing grade by like 1%. That sucks. Question on a test with function with multiple function description, 5 parameters, A to F with 4 statements, where you figure out what each parameter. Oh no. So it was a function like f of x equals like some huge thing, or like one function there, one there, and there. And they all have like, I guess maybe like ax squared and then bx plus c or something. Yep, not really. Okay, I don't know. I am, if I'm half right, then I'll take it. Me as Hollow Knight. Ooh. Um, it's a good one. Okay. Okay, we got a blank page here. I just re-enabled that redeem. I felt like it was time. So let me bring in a reference picture here. Images, Hollow Knight. Okay, that's a good reference picture. Wait, that's the link on the image. Ooh, that's a large and in charge reference picture. Okay. Okay. Let's see. Uh oh, so like that, Lucas. Okay. Yeah, fair enough. Do you recommend Hollow Knight? I enjoyed it a lot. Um, and like Fanny Highway really likes it. Megalomorph really likes it. Maxi does. Like a surprising amount of people in the math community like came out of the woodworks to like watch me play it. um, and I enjoyed it for myself. Okay, so I guess we got to have our horns. Thankfully the face is really easy. Now we got to get some glasses here. We need a beard, and I'm not going to be a bald hollow. That looks terrible. Do I have a circle tool? Ellipse. Can I make it a filled ellipse? Or am I being picky? Uh, I think that's it, the tool. No, that sure is not. One of these things up here, I thought toggles the shapes to be filled. So that? Well, okay. This isn't really an art program. That might be the best that I can do. Annoyingly. Can I even? Okay, yeah, I can. Okay. Let's get some glasses. Oh no, stop filling, please. Uh, okay. I guess I should at least get a little bit of the body before I fill in the beard. I don't like. Okay. Dude, I am concentrating really hard on this. Drawing is not my strong suit. I wish it was though. Should I? What's something funny I could have instead of a nail? Like, what would my weapon be if I was the Hollow Knight? Hmm. You know, I feel like Hollow Knight would be a lot easier if I could have an AK-47. Hey, Central. See, I don't know how easily I'll be able to convey this is supposed to be an AK-47 just from like having it slung over my shoulder. Plus, I do enjoy me a good AK-47 in DayZ, so um can I get my hair like um this might be a little bit extra here, but that's why we have undo buttons, right? My hair is very like straw like, but you know, it works. And also like having horns and hair is a bit of an issue. Dude, that thigh gap though. Oh god, my legs are not even close to symmetric. There's no like fill bucket tool in this, right? I'm not being stupid. I don't think there is. Yeah. So let's try to shade in my little legs. And we try and put some highlights on the cloak too to give it a bit of color. You love it? I'm glad. I wish I was artistic, but can't play instruments, can't draw. I don't know if this is making it better or worse, this blue. Maybe I should have. I don't know. I think it'll look bad if I try to shade in the entire thing in blue. For me, I should have done this line work in blue. Altering brain hemispheres can increase overall mental performance. Oh yeah, like trying to do different types of mental exercises. Like I've heard that uh like bilingual people are way less likely to get Alzheimer's or something like that. Because it just like engages completely like or like switching from one language to another is a really good way of exercising your brain. This might be my completed drawing here. Not sure what else to add to it. Yeah, like drawing can do a similar thing. Playing an instrument. I look like Fabiano Caruana? Really? I'll take it, but I don't see it for myself. All right, this will get posted in the Discord here. Thank you for the redeem. This was a lot of fun. I turned it off once I switched to the like electronic um like journal plus plus program. Because it didn't feel the same as drawing on a whiteboard, but it's still fun. Ramchandra, my Twitch mods are also mods in the YouTube chat, but I also recently modded Territar. Often they just like lurk, if anything, but usually there's not really a need for a mod on YouTube. It's just we sometimes get like trolls and waves, and that's the only time where it's like important, I guess. Okay, so we answered part A of this question. Part B. We're taking the same region here, rotating it about y equals 6 up there. Interesting. This is, I guess, a job for washers. Do I... Wait, I guess I normally use... Why was I on the thin pen? Am I... What pen thickness am I normally on? I think I'm on the medium one. It's gonna bother me. I'm actually gonna check a VOD because I'm like... something about this feels off. And for whatever reason, I cannot move forward until I figure this out. Teoi Triu, thank you for the follow, and sorry for butchering your name. I'm normally on the large one, apparently. Okay. I don't know why it got switched. That's why I'm messing with it when I was drawing. So we're doing washers. So we're gonna do pi 0 to 5 for sure. That's not, there we go. Sorry, not 5. The intersection point we just found, ln 6. And then the outer function, since y equals 6 is, ugh, up here, the outer function is actually going to be the exponential now. The radius of that is the function 1/2 e to the 6 plus 2 minus the y value 6 squared. And then we subtract out whatever is between y equals 5 and y equals 6. So we do 5 minus 6 squared dx. And this is possible by hand, so let's do it by hand. Hey, Siren. 1/4 e to the 2x. So that's, that's good. This is annoying to, okay, I'm just gonna replace that with a -4. So I can square it in my head. It'd be -4 e to the x plus 16 minus 1. You know what? Why don't I just erase the plus 16 and -1 and make it a 15? Sire, do you know the volume of the shaded region? Like, the problem I'm working on right now? So the problem I'm working on right now is one function is y equals e to the 1/2 x plus 2. The other function is y equals 5. Oh, just in general? Well, yeah, I mean, I guess I'll use this one as an example then. You're normally given a couple of functions that make the boundary of the region you're trying to find. And so if you want to rotate it, in this one we have y equals 6 that we're rotating about. And so I'm using what's called the washer method. And so the washer method, the formula for it is pi integral from a to b of, I'm going to say f of x, but we need to say what f of x is. Well, no, I won't even say that. Outer radius. This should be a function, but I'm just going to write words here. The outer radius squared minus the inner radius squared. And so the outer radius depends on where you're rotating around. So we're rotating around y equals 6. So the function that's farther away is this exponential function. That's going to form our outer radius. In the radius, in the distance from the function to the axis, you pretty much always just do the function 1/2 e to the x plus 2 minus the axis, so -6. And that's what I get for erasing things. That's why originally I wrote that as my outer radius. And then the inner radius, we just have the constant function y equals 5. I mean, the idea is that this is the, we're using the area of a circle. The area of a circle is pi r squared. And if you integrate an area, you get volume. What we're basically doing is making a bunch of circles that are centered at y equals 6, and have radius determined by the distance from 6 to the function. So here we get a big circle, but all the way on the right here we get a very small circle. And we're taking all those very thin circles and adding them up. And then this one is a little more complicated because we also have this inside radius. So it's not a solid circle. There's like we're cutting out a little piece inside of it. Like this part here is empty. This one is going to look almost like a volcano, I guess. Where it's going to get like more and more narrow. Well, I should draw this right. And there's gonna be like a crater or like a hole at the top. But it's almost like a mountain with a hole cut out in the middle is the shape that we're getting here. It's a very weird thing to visualize. But that's kind of the idea of it. All we're doing is we're making a bunch of circles and stacking them on top of each other. And those circles have different radii. So I hope that helps a bit. And that's just the idea for washers and also discs. That's fair enough, Cyrem. I might just point you towards Paul's on my notes then, if you want another explanation. So I might try looking through this web page instead. They have a little bit better visuals here for why this formula is the way that it is. Okay, so what are we getting when we integrate here? Edison, you're trying to prove the binomial theorem by induction. For integer n or any? I assume just like for integer n. That's an interesting question. I haven't done it before, but I assume I can figure it out. Let me finish up. Well, this person isn't here. We can just go straight to looking at that. So you want to prove that by induction. How hard does math actually get? Well, it's kind of once you get through calculus, usually you get a whole bunch of different branches of math opening up to you, and you can choose any path you want. Like it's like your educational like journey up until like you do algebra, geometry, pre-calc, and then um, as soon as you hit calculus, you get a whole range of things that kind of open up to you, and they're all um, kind of they have overlap, but they're pretty different, and different people find other areas easier or harder. So like linear algebra is the matrix thing. Math guy, I am, yeah. I was about since that person who asked it isn't here, I was thinking I might just switch to this question from Edison. Unless you're the Viking, please let me know if you are. Um, I'm kind of like switching around between a couple of different questions at the same time right now, to be honest. So I'm sorry if it's confusing. So there's like linear algebra, analysis, um, differential equations. Like, there's absolutely a bunch of overlap. I mean, and even things that I even like. There's just a bunch of things that you can choose. And so the epsilon delta thing is not a bad test for whether you might like analysis. It is a very tricky thing. And so, like, I personally find analysis pretty difficult. But I could go over to some other branch of math, like differential equations, and it's not easy, but I like it a lot more, and it's easy. Um, and I find it easier because I like it more, I guess. Not because it's easier for everyone, but so yes, it gets harder, but you can kind of choose. You can pick and choose what sub areas you go into more. That you like. My like equals really essential, yeah. Um, yeah, just math guy. I will come back to that. And Edison, I will work on this proof too. It's confusing. It's something to do with your order operation. Formulas figuring out half quickly why they work. It's really difficult as you go further. Once I did actually somewhat understand Epsilon Delta, the calculating thing was fun to do. Fair enough. So, like, math one has a ton of a fucking ton of theory. There we go. I can speak. Um, so you might be like me in like applied math, but if you are finding enjoyment in epsilon delta, like you might want to look more into analysis. Um, but I want to work on this proof by induction here. Yeah, math does tend to get pretty proof heavy in general the further you go. If you stick towards applied math, you still need to do some proofs. Uh, yeah, I mean, you definitely could, Luke. It's like you could definitely like start with that, and if you find out you like a certain piece, you can always switch majors. I started out as an engineering major and switched into math. Um, and Elliot PA, welcome in. You want the series expansion of cosine about 0? If you just want the answer, I'd say this right here. If you want to justify it, we can talk about that if you want to, but I want to get through a different question first. Go apply for FAFSA? Oh yeah, that's a good idea. Who even does engineering? Well, not me. That's for sure. No worries. From France, awesome. If you're interested in math streams, since I see you're new here, there's a whole list of people who stream math. I know that Penn Center in that list does speak some French. If you're feel more comfortable in that language. I don't know how comfortable he is in it, but I believe he speaks some. But yeah, whenever I see a new face, I just like to let them know that we all exist here. So if I'm not around, there are other people who do math help also. Um, okay, so I'm sorry I'm getting distracted. Uh, so this question I'm going to put on the back burner just for a little bit because the person who asked it isn't here right now. Edison in the YouTube chat asked to prove the binomial theorem for integer n with induction. I don't know if I've done it before. I probably haven't. Prove via induction for integer n. But I imagine I can figure it out. So let's try it. N equals 0, or I simply want to take n equals 2 as a base case here. Because 0 and 1 are a little too easy. Consider YouTube to pipe for actual math related topics for Ian Suki for some fun and chill talk. Yeah, that's fair. We all have our own like strengths. Yeah, Lucas, like some people on the list stream at pretty bad times for you. Um, 2 choose 0 b squared plus 2 choose 1 ab plus 2 choose 2 a squared. 2 choose 0, that should just be 2. No, I'm sorry, it should just be 1. 2 choose 1, it should be 2. And then a squared. So base case checks out. Dallas is one of the people who streams at a bad time for Lucas. So I wouldn't expect Lucas has been able to watch Talos much. Yeah, it's I think Talos comes from Greek mythology. So that and Talos is a god. Yeah. um Proof should generalize to arbitrary commutative rings of identity once one treats NX as canonical group. Oh, really? Huh. I guess that shouldn't be surprising that this can generalize further. Um, okay, so the base case is that then we assume this thing works for an n. It's technically bad form to reuse n here, but I'm a rebel, so I'm going to do it. I didn't add the right type of page. This page sucks. We're getting rid of it. That's the type of page I want. There we go. Now we need to prove it for n plus 1. I don't know why I'm copying it again. I already had it copied. Okay, so why Dutch time sucks. We call 10:30 as 11:30. That is terrible. Um, the craziest one that I'm aware of are Danish words for numbers. Because they literally like use fractions to express whole numbers. It's like I forget exactly how it works. It's like the Danish word for 45 means like 2 times 22 and a half or something like that. Oh yeah, French also has super like messed up words. This is where you get stuck. Yeah, I'm getting this is it's definitely weird. Um, I think what I want to do, maybe I'll start from the left side. Because we want to look for any situation where we can apply our assumption, and we can apply it here. Replace binomial equation with its own formula. Oh yeah, with factorials. I assume it wouldn't be necessary, but maybe it will be. It might be if we want to get an n plus 1 there. French word for 82 is 4 times 20. Yeah, yeah. Okay, so what I want to do here is just like distribute the summation to each of those. I think. I hope this helps. It might, yeah. Maybe. Because what can happen now is we can bring the A and the B inside the sums. And we can group them back into one summation. Besides, you haven't gone to school. Uh, it's hard to explain from the ground up. I can definitely try to do it, but let me let me try to figure out if this is even like a good direction to go in, and I'll try to come back around and explain it. Hey, oh shit, I forget how I was pronouncing your name, but your system equation you've been showing solve. Yeah, feel free to tell me the question. You can put it there in chat or in my Discord server if that's easier. Um, I'm working on this question, and then I think I can get to yours. What do I do when I can't focus? Usually just like allow like set allow myself just to take a break. But promise I'm gonna come back after a certain amount of time, like 10 minutes, 20 minutes, 30 minutes. Because if you can't focus, you probably um are tired. I mean, it depends. That's often why I can't focus. Um, yeah, this isn't easy. We need to notice something about how these two things are interacting with each other. Like I want to be able to justify saying this is equal to this. It should be. Um, oh, okay, I see you put the system there. Ooh, that's an interesting system. Uh, I'll copy it down. Um, and then I'll like I said, I'll come back to it once I hopefully deal with this question. You definitely want to do some substitution there. I'm not sure exactly how, but um, no wait, it's three equations. That was three equations, right? There's three equations in here. Um, the first one ends at 41. Yeah, yeah. So this like you mean like this, right? Quick question about probability. Uh, I'm trying to do a proof by induction, and then I he told me how to pronounce your name, but this person's system of equations. If it's a quick one, I can try to squeeze it in though, Jed. But those are the things I have like pending immediately. And then Lucas wants to know a bit about like what a summation is. This one is not an easy summation to get introduced to at first, though. um, actually, I am a little bit stuck on this anyway. Let me just quickly say, I think Maxi is helping you out, Lucas, and thank you, Maxi, for doing that. Just to like show it in writing here, because it's sometimes easier to see it like that. Um, this is capital Greek letter sigma, and we usually write the variable and where you start from and at the bottom, and then wherever you end at the top. So if you sum from k equals 0 to 10 of just k, then it's 0 plus 1 plus 2 plus... I should have chosen a smaller stopping point. How about 5 plus 3 plus 4 plus 5? Where it gets more interesting, though, which this actually, there's a lot you can do with just that. But you can also have like functions inside there. So if you want to sum k squared, or even like sine of k, you do like 0 squared plus 1 squared plus 2 squared, 3 squared, 4 squared, 5 squared. And there's interesting formulas where if you know this summation, we can say that exact one is actually equal to 5 times 6 over 2. So like this is an expression that has no summations inside it. It starts at 0. Yeah, exactly. It starts at 0, ends at 5, and you plug that in for whatever is inside your summation. So here at k squared, you could have sine of k, you could have ln of k, you could have k plus 1 divided by k plus 2. K equals 1/2, we usually don't do stuff like that. If you're careful about saying how you increment things, then sure. But normally, if you need fractions, you would try to get the fractions involved somewhere there. So if you wanted to like add up halves, you could do like k equals 0 to 5 of like k over 2. And that'd be like 0 over 2 plus 1 over 2 plus 2 over 2, like that. I think it's just whatever k is set equal to their maxi, right? Oh, top is less than the bottom. Yeah, yeah. That makes sense. What about k is another sigma? I'm not sure what that means. But like you can use whatever letter you want there besides k. Sometimes I or n or whatever. God. Uh, that probably. Oh wait, cosine of pi over two. Oh no, I guess you're getting alternation. I don't think it. Um, I know that's a quick like speech on how summations kind of like work in their basic version. Oh, if k is another sigma, okay, yeah, it's an. Um, thank you for clarifying what Lucas was asking. If k is another sigma, like if you have another summation down here, as long as you can figure out what this comes out to be, you can then do the bigger summation. It's like if you had L equals 0 to 2 or something. If you can simplify that, then sure. I mean, n is usually used just to mean a natural number. It's like usually n is 1, 2, 3, 4, 5, and it may or may not start with 0. But usually that's what we mean with n's, or even like integers as well, I guess. It could be like negatives. It depends on the actual context, but it's usually like integers or natural numbers. Um, sigma k of n. So you give like the sum from k equals 1 to 5 of n. Um, well, in this case, n has nothing to do with the summation, so you could factor it out front. Like the summation only cares about anything with k, and there's nothing with k there. So you get the sum of just 1. So you'd have whatever n is, it's just some number that we don't know. And if you sum 1 from 1 to 5, it's 1 plus 1 plus 1 plus 1 plus 1, just 5 times. Um, okay, so we're getting some questions stacking up. Edison, I might need to just Google a proof for this because I'm getting a little stuck as well. Binomial theorem, natural number, and induction. Okay, so I have the matching steps up to here. What happens next? Oh wait, then he undoes that? What the? Okay. By expanding this, get that. Oh, you need this identity. Yeah, I feel like I've probably seen this before, but I would not have thought that this exists. Oh, this it probably is a Pascal's triangle thing. Why this thing is true? It seems like a Pascal's triangle thing. Um, so how does this apply to that? Um, oh God, Papadoria, that looks terrible. I need to make a queue here. Since they're starting to stack up. Jed asked a question too. Or Jed said he wanted to talk about something. Okay, that's the queue as it stands right now. If you think it'll be quick, then I can bump you up to right after this. 1a to the n minus 1b plus n choose n a to the n plus b, same thing. Yeah, or if you just want like put it there in chat, so someone might just answer it before I can. Should save me a little bit of time. N choose 1, a squared b n minus 1, n minus 1, a to the n b plus n choose n, the n plus 1. Yeah, I was a little surprised that the 2r squareds don't just kind of go away there. Or like that we were able to solve for them. I haven't thought about it enough yet. That problem though. Because they usually need the r's to be different. A to the nb. Okay. So I assume we want to I guess the i's stay the same. Like what we want is a k plus 1 in this. K choose I plus k choose I minus 1. So this is the version of the identity that we want to use. Because we want a k plus 1 in order to prove that. Or n plus 1, but yeah. So if we can match, we have an AB to the n. Ah, yeah. This is how we pair this and this because the A's and the B's are the same. Can you take the SAT to do an issue in the blue book? Oh no, Joe Mama. That's annoying. Did they let you like retake it or try again with it? Okay, so then using the identity that we just looked at, that's n plus 1, choose 1. AB to the n. Supposedly getting an email in a few weeks. Okay. Sorry, I should have written that in green. And then let's look for whatever matches the a squared bn minus 1. Oh, we don't actually have that written out here. Getting SAT results this Friday. Ooh. Good luck. Oh, okay. I was trying to pair up these two numbers, but we do not pair those up, right? Those are going to be on their own, and that's a good thing. So I'm going to put n choose 0 beats the n plus 1 there, plus, and then n choose n, a to the n plus 1 will be way over here. Okay. Yeah, I think this is the idea here, Edison, that we can pair these up strategically, and we'll get our progression. Ooh. Wait. We need a plus 1 there. Oh, wait. N choose 0? Oh my god. N choose 0 equals n plus 1 choose 0 equals... No, it doesn't. Wait, is it 1? Anything choose 0 is 1, right? Yeah, I think that... Oh my god. So we can just make that an n plus 1 and call that good. Same over here. N choose n is equal to n plus 1 choose n plus 1. Oh my god. Thank you for confirming that, Endaro. What term do we get here? Because if I can even just get this term, I might feel satisfied with collapsing it back into summation. It's gonna match with that term. So a to the n b, there. Those two terms we match. Because we can use the identity here to get n plus 1 n a to the n b, right? And so you probably could like try to do a few more terms to really justify it, but I think this is good enough to collapse back into a summation. K equals 0 to n plus 1. N plus 1 choose k. A to the k, b to the n plus 1 minus k. And that's the exact thing that we wanted to prove up top. So I think, Edison, the really tricky part is expanding the summations and pairing them up strategically so you can apply this identity that I had seen in forever and didn't remember existed. I hope that helps. I do really need to move on to the other questions, start getting through queue, or like through the queue that's formed. But let me know if you have any questions. Sounds good. Okay, so Jed, do you want to ask your probability question? Oh, nice. You have it queued up. Mr. and Mrs. J have 3 kids. Oh gosh. I'm sure, Mr. and Mrs. J, the J definitely is not Jed. And sorry, after this, we will do the system of equations. Since Jed said this would be quick, I just wanted to see if I could get it done quickly. Because that system is probably going to take a little bit of doing in order to solve. This feels like a problem that like Zach would make for one of his classes. Okay. I mean, Mr. J did something wrong. Okay. 2 people told Mr. and Mrs. J have 3 kids 2 weeks ago. They realized that the kids would be out of the house for the weekend, so Mr. J suggested Mrs. J she thinks things they can do together, activity, dinner, etc. One day prior to the event, Mr. J showed several options to Mrs. J about possible dinner options 5 minutes before his last kid needs to be dropped off. Mrs. J asks Mr. J, so what are we doing? Mr. J replies that several options are presented. For Mr. J to pick one. Mr. J gets upset and decides they'll just plan to do something another time. But it's probably that Ivy and Mr. J did something wrong. Oh my gosh, I get it now, why it's quick. Well, there's a well-known axiom in math. Sorry. Well, it's called the axiom of J, and well, of Mr. J, and it states that Mr. J is always correct. So I think we just cite that axiom and say 0. Ugh. That is very annoying. Probably this is yeah, that's where there is an important proposition, I guess, that we can prove using the axiom. We'll always disagree. That doesn't mean that the axiom of Mr. J is wrong. But, if Mrs. J is operating from her own set of axioms, there might be a conflict here. Oh gosh. That reminds me of like being a kid and my parents would ask like my sister and I what we want to eat for dinner. And I'd be throwing out a bunch of options and my sister would always say, no, 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 I don't want to do that. This gives me a very similar vibe. What if Mr. J says Mrs. J disagrees with me on all things? Okay. Well, as Gödel proved, you can't make any logical system without contradictions. So, like, there's always going to be something wrong with anything you try to prove with axioms. Well, okay, I guess not there's always a contradiction, you just can't prove whether there's one or not. That's what the incompleteness theorems say, don't they? It's not complete, or you can't prove it's complete, you can't prove it's consistent, and you can't prove something else. That's what I thought, at least. I'm literally just repeating things I learned in a class. Okay, thank you for your patience here. Well, let's try and get through the why I try to scroll up in chat and I'm being punished. Why would it do this to me? We're given that A and B are between pi. Okay. 0 is less than A is less than pi. 0 is less than B is less than pi. Okay. So I guess a natural thing to try here first, if we want to solve this by hand, is using an identity on that cosine. Um, I believe it's cosine A cosine B minus sine A sine B. 186 is 14 squared. That becomes important. Let me verify that identity. Got it right. Got into a quadratic in R squared. It was messy. Okay. Well, this is terrible, actually. This is not a. I don't know if using this identity is a good idea. We can't isolate cosine A or cosine B. Yeah, no, Max. Maybe I was just given the baby version of those theorems, but uh, I feel like I remember pretty well at least what my professor what was telling me in that class. Um. Oh, I mean, I guess we use the first two equations to, I guess, get cosine A and cosine B, and we plug them into this third equation. Okay, so if 2r squared 1 minus cosine A, 41 is a mean number to be given. But let's isolate cosine A here. 1 minus 41 over 2r squared. And so if cosine A equals, I guess let's get a common denominator. If cosine A is that, then that's adjacent, and that's hypotenuse. So sine of A will have the same hypotenuse, but the opposite will be 4r to the fourth minus 2r squared minus 41 squared, right? And that simplifies 2 times 41 is 82, times 2 is 164 r squared. That'll flip to be positive, and we subtract off 41 squared. Who even knows what that is? $16.81. If you have that one memorized, then I applaud you. Oh, yeah, that's fair enough, Cytos. Oh, this is the difference of two squares. That's not helpful, though. This is going to be a terrible problem. We have the Papadoria question and then also the Cells of Revolution one. Well, yeah, you gotta go completely different direction than him, but got stuck here. So I assume maybe you're trying a similar approach as I am. We can do the same exercise now with the second equation. Cosine B. You may have a solution? Ooh, okay. Common denominator. Oop, 2r squared. Sine of B 4r to the fourth minus 2r squared minus 125 squared. 2r squared. Okay, so we get 125 times 2 is 250, times 2 again is 500. R squared, that flips to positive. 125 squared. Okay, that's 25 times 3 squared. 25 squared is 625. 3 squared is not 9. No, wait, 25 times 3? What am I saying? I'm smoking crack. 25 times 5 squared. 25 times 5 in parentheses squared. 625. I'm not doing that. Wolfram Alpha is doing this for me. 125 squared. 15,625. That is definitely a number right there. Can't say it's not. Can you factor perfect square out of that? I'm saying a result for R. Okay. Can we factor, like, 25 goes into both of these, right? Oops, I didn't mean to do that. If we factor a 25 out, we get a 5 here. 500 divided by 25. 20? That divided by 25. It's probably, I'm betting it's 625. I'm not gonna, it is 625. Well, look at me go. Okay, so we know, I guess we can come back here. We know cosine A, cosine B, sine A, and sine B in terms of R. It's gonna be terrible, but we can get one equation in R now. One minus, okay, cosine A is that. Wolfram alpha is gonna do this next step once you write this out. Times cosine B. 2r squared minus 125 over 2r squared plus sine A, that bad boy. $1681 2r squared times that bad boy. I'm running out of room. I was ambitious. With starting to write from that far over. Just erase it and rewrite it. Equals 196. Okay, that's what Wolfram alpha will solve for us. And once we get that for R, the rest should fall into place a lot easier. Two R squared. Already off the bat start, wrong parentheses. 1 minus 2r squared minus 41 over 2r squared times 2r squared minus 125 over parentheses plus square root 164r squared minus 1681 over 2r squared times 5 square root 20r squared minus 625 over 2r squared. Parentheses, 196. Did I answer this right in one go? Let's find out. I think I got it. I think I copied it down right. Root 205 over 2. Hey, that matches what Fenbox said. I'm not going to solve that for myself, but I guess it is just a quadratic. It might be a quartic. You mean Wolfram alpha? That's a better way. Watch it 55 times. Actually looks fine as most denominators cancel. Yeah, that's true. Oh, yeah, it'll just be a quadratic. No, it'll be a quartic. You do get that r squared times that r squared. You don't get any odd powers, though, so you can treat it like a quadratic and take the square root. You did it without a calculator? I mean, the denominators all canceling is a good shout. I still don't want to do stuff like 41 times 125 though, and stuff like that. Or actually, no, the square root. No, I don't. I'm not doing that by hand. I'm, I'm just not. But now we know R, we can get A and B. Ishan, the question is to solve this system of equations here. We've already figured out R, and that's the hard part. Hey, Rapture Tech. You use the sum angle formula for cosine, square both sides to get the sine terms back in terms of cosine. Oh, you isolated the sines on one side? 7.33%? Nice. 750. Okay, so Wolfram Alpha will solve A and B for us as well. It is very disgusting. I agree. Okay, so R is root 2 of 5 over 2. So 2R squared times 1 minus cosine A. 41. Three over 5? It's a Pythagorean triple? No. This is not a triple. Pythagorean triples. Hell no, Isha. I'm not doing that. Which one of these has 41 inside it? Control F, 41. That one does, but that's not it. No? Well, I mean, I guess it reduces to 3 over 5. Yeah, right, I know why I'm looking for 41. It's literally just 3, 4, 5. That's crazy. A 3, 4, 5 triangle, is that a 30, 60, 90? I don't think it is, but it's still a special. If it's 3, 4, 5. No, the angles aren't special. But yeah, we could do arc cosine 3 over 5. I guess there's two solutions if they're between 0 and pi. So 53-ish degrees. We agree for... Is root 2 of 5 over 2 about 7? Yeah. So math guy, I think we agree. That's the result for A. Your friend made this question. Oh, nice, Ishan. B 125. Well, that's not as nice. Arc cosine negative 9 over 41. $102.7. So just like a degree off, plus a bit of change. Oh, I didn't see that you put those there, Fembox. So is 123 prime? Well, no, it definitely doesn't have 5 as a factor. Arctan 1 plus root 2 without using a calculator? Does it have a summation identity, or there's probably I don't know. 1 plus root 2? Oh, it's probably something stupid like pi over 12, right? Okay, so yeah, I guess I hope that's a satisfying answer for you for this system of equations. Um, if you're willing to shove enough symbols around a piece of paper, I guess it's not so bad. But once you have any questions about this, I'm going to move on to the next one. Are there any other units of trig functions? The only ones you know of are radians and degrees. I think gradients is a thing. I don't remember how they work though. Or is stir radian the thing? I don't remember what that is. But I think they exist and have niche. I don't really remember, to be honest. It's 3 pi over 8? Okay. Copy, copy. Mm-hmm. I, I haven't even read this through yet, Papadori, but I guess we're at the stage where we can talk about your question. It looks difficult, but let's see. Oh yeah, copy is my hobby. Is this, wait, is this cosine A plus I sine B? Like 1 over A. Or no, wait, C. Oh no, there's a space there. Oh my god. Never mind. Yeah, thank you. I'm so used to using CIS as a abbreviation for cosine plus I sine. Um Using arithmetic sequence in that order. Prove that the GCD of A and B is more than 1. They're not coprime. What? There's no way that has to be true. Non-transients are variables nowadays. Yeah. Apparently. Yeah, those energy drinks got a little too addicted. Oh yeah, I hate energy drinks. I think they taste disgusting and they're not good for you. I feel like wait. What about 1/3, 1/4, 1/5? Increasing. No, this is decreasing. Um, but I just reverse the order, right? Wait. Yeah, I'm not doing this right. So uh, 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 what's an example of A, B, and C that work? I'm getting really confused. They have to be integers, A, B, and C. Salvador is saying since it's arithmetic, you can say 1 over b equals 1 over a plus d, and 1 over c is 1 over a plus 2d. Sure. Benbox is saying b equals 2ac over a plus c. That feels like a thing I've seen for for arithmetic sequences. And that would mean that b has a as a factor. Well, you have to prove it's an integer. I don't know. This is probably the key fact though for part A. You're gonna eat? All right, just math guy. Thanks for hanging out. Enjoy your food. Maxi suggesting a half, a 6, and minus a 6. And so the difference here is negative a third each time? Oh, positive. Yeah, we can't choose negative 6. So we can... No, we can't. Yeah, I forgot about that too. Thanks for pointing out, Papa Doria. Yeah, the one in the numerator is what's really like tripping me up. uh, we need a plus c to be divisible by a plus c. Yeah. Um. What happens if we play around with this? Like we multiply each side through by c and a. We get a equals c plus 2dac. A DAC. That's an audio term. Anyway. DAC mentioned. I got a DAC right here on my desk. Well, it's basically a paperweight. Like I use it, but like they're apparently not very useful. As if you're just like using headphones. Um, yeah, same Bubbler. I'm bothered by the one with the numerator here. I'm sorry, it's sad. I'm already being tortured enough. I that question also looks terrible. Famous. Okay, yeah. If you're no solve it, I might just like uh do it briefly, but I can take a look at it. Oh, okay. I since that one is so quick, I'll just go and do it now. You just need to simplify -2 to -4. Oh, so there's an important distinction with a problem like this, where there's a huge difference between -2 to -4 like this, and -2 in parentheses to -4, and I'll show you like what that is. Sorry, I'm just switching gears away from this problem Papadori because this one is so quick. In order to deal with the -2 to -4, I would think about it as like -1 times 2 to the -4, just to really like draw this out. And then 2 to the negative 4, if you have a negative exponent, you can basically flip it. So 1 over 2 to the 4. In 2 to the 4, if you know your powers of 2, is 16. And negative 1 is just a negative number. So I'd say it's minus 1 over 16. This negative 1 thing is a little bit unnecessary. You could just keep the negative sign in front the entire time like that. But I'm showing it. Oh, really? They have you doing it the same way? Okay. I'm showing it because there's a huge difference over in the case on the right where it's really helpful to see it here where you can think of it as negative 1 times 2 to the minus 4. And when you have parentheses with an exponent, you can kind of like distribute the exponent to each number as long as it's multiplication. So it's like negative 1 to the minus 4 times 2 to the minus 4. And so we can do the same flipping thing. 1 over negative 1 to the 4th times 1 over 2 to the 4th. And negative 1 to the power of 4, well, minus 1 times minus 1 times minus 1 times minus 1. These two are positive 1. Those two are positive 1. So it's positive 1 times positive 1, which is just 1. So this becomes 1 over 1, which is just 1. And then 2 to the 4 we said is 16. So we get a positive 1 over 16 at the end of this. And that's why these, like the distinction between these two is very important. Because you'll be flipping a sign. Hey, Lycan Dragon, how's it going? So normally when I normally do these problems, I don't show it in this much detail. I would just keep the minus sign out front. But just for the sake of showing like how this actually works, like that's what's happening here. But yeah, I hope that helps. I hope that helps. Okay, so let's go back to thinking about the sum. Yeah, as long as it's multiplication. If you have like a plus there, then what I just said is no good. This 1 equals minus 1. Oh wait. 1 to the 1/2 is equal to negative 1 to negative 1 to the 1/2. Is that just not a good thing to do with fractional powers then, Maxi? Or is there an error in that little proof you put there? I'd be interested to know. Okay, Papador, I said a very small terminology question. You know, I think times 0 equals 0, and d by dx of e to the x is e to the x. What is that term called when applying a given operation to it returns the same thing? Fractional powers are fine as long as you don't have negatives to fractional powers. Okay. Interesting. Terms are not defined for bases less than 0. Ooh, funny. That's a weird like subtlety where I've heard that but before, but like I don't remember like ever running into issues with it, but I think there are technically issues. Yeah, so the terminology for what you're saying, Salvadori, I think is identity, But 0 was not the multiplicative identity. 0 is the addition identity, and 1 is the multiplicative identity. As far as I know, 0 with multiplication is just a jerk. It's not really. I don't think it has a name. Maybe I might be like misspeaking there, but like I guess e to the x would be the identity for derivatives. But yeah, it like the idea they're getting at is identity. A e to the x, yeah, fair enough, Maxi. Okay, so what's up with this arithmetic sequence? Then it's usually a word used for binary operations. Okay. Oh, I probably missed that. Yeah, I did miss that chat. Thank you for repeating it. Papadoria thinks that the GCD of A and B is equal to the GCD of A comma A minus B, where A is greater than B. That's not B. Differentiation is unary. You probably called a fixed point. Oh, yeah, fair enough. Um, this feels like a mod thing. Like it, um, if this thing works, that A is greater than B. What's happening? I guess that checks out. Hey, Stoffel. I guess with that simple case. Um, that's probably a better thing to Google. GCD A minus B. Okay, I'm just gonna say that it's true. Wait. Okay. Yeah, what's up, Lycan? Is GCD B A minus B? Oh, I think that the Reddit thread might have actually made the same mistake in correction. Yeah, it did. um, is this helpful? You despise your professor but respect him for how could he teach at the same time? Ugh. He gives you such challenging problems. I still can't name it an A, B, and C that even follows this, but assuming that they exist. Kind of question is this? I don't know. And I see the part B is just the same question with a geometric sequence. I think this is a good old-fashioned Googler. One ten, 1/15, 1/30 might work. Papador is saying 632. You're taking off a third each time? No, I don't think that's the same. No, you're taking off a sixth each time. Oh, I guess that might work. Okay, fair enough. Google's failing us. Yeah, that's the linear combination thing, Amit. Um, uh, the actual question isn't visible right now. Damn, I can't find the actual, like, this might be an original Papadoria professor cooked up question, which is the most terrifying kind. Yeah. So, yeah, the question that we're trying to do anything with at all is here, but I'm a little stumped by it. Yeah, that Colette's conjecture one was hilarious. Hmm. Converting it to a linear equation trying to prove it's greater than 1. Yeah, I might need to move on from this Papadoria, but I don't know another question I immediately need to get to. There's still the one that I was starting to stream out from I was posting in the Discord that I need to get to at some point, but until I see a question from Lycan Dragon or I guess from Soffle, if you want to post yours, I'll keep thinking about this one for a bit more. You have it ready? All right. You forgot someone? Okay, I'll wait for. Or do you want to like tell me what is, or are you gonna post a new image? You updated it? Okay. And like, and since you asked for Cell, think about your question first once you post it. I'm just getting this one queued up. So the question I assume is to simplify this, given this is true. I forgot that when we have minus 7x in parentheses raised to the power of 0 will apply to the whole expression equal 1. Yeah, exactly. Except 0 itself. But is this going to be some golden ratio thing? That x plus 1 over x usually has something to do with the golden ratio. I forget exactly why. No, actually? Okay. Um, I see Lycan is working on their question. I'm starting on this one, but as soon as you have completed your thought, Lycan, I'm thinking about your thing. Um, well, that's terrible, isn't it? Probably shouldn't do that first. Well, we could try to figure out what this looks like multiplied out. The x to the 6 will cancel with the x to the 6, and same with the 1 over x to the 6. And we only really need to know the coefficients, right? It'll be 6 choose 1, 6 choose 2, 6 choose 3. This wouldn't be the worst thing to expand out, I don't think. It might not be helpful to expand it, but I think it's probably worth a try. They'll all be negative. Um, n choose r is n factorial over r factorial n minus r factorial. Okay, it looks like and you've outlined it all, so let's start thinking about it. Sorry, I'm jumping between questions here, but I'm trying to have a balance between not having downtime on the stream and answering people's questions in the order that they ask them. Okay, so like in this 2 game, the game when you take a pool of 10-sided dice and roll them. If the roll is 8 or higher, that counts as a hit. Let's call the number of hits here per n dice h1. In game 2, I take the same pool of 10-sided dice and roll them. In this time, the game seems false. The target number is 8, but is now x. Die that rolls a 1 now subtracts from number of hits h2. For a number of dice n, what is the value of x you should choose to make the expected value of h1 and h2 equal? Ooh. How do we figure the expected value of h1 for n dice? They're 10-sided, we need 8 or higher, so that's 3 good possibilities out of 10 total. N many times. And each hit is just worth 1. So we don't need to worry about multiplying by anything. This is an should this be more sophisticated? This feels like a binomial. Isn't this? I should do a binomial distribution here, right? Or it's the expected value of a binomial. Okay, yeah, this is basically like Bernoulli trials or whatever. It's what's the expected value of a binomial distribution? Is it NPQ or just NP? It's just NP. NPQ is probably standard deviation. So I'm going to say it's n times 3 over 10. Now h2 is a little bit trickier. It's not quite binomial distribution. It should be linear though, right? So we can get the expect. Well, no, they're not. No. Trying to convert some mechanics from different tabletop game editions, where the way you roll differs slightly when porting them over from first second. They're roughly the same distribution. Oh, interesting. Because if I was doing this personally, I'll probably try to simulate this with code. Otherwise, I wouldn't feel like super like confident. But this is an interesting question to think about and try to figure out the probability way. So the thing I was gonna say is try to take the expected value for x or more and subtract the expected value for 1, but I don't think that's the way expected value really works. Boils down to because 1 to now subtract hits, you have to lower the value of x from 8 to bring the probability back in line. Yeah. Um, okay, so if you have n dice, Ross apps are due today. Just need to finish from the problems in the set. Am I cooked? I don't know what Ross is besides Ross Dress for Less, that store. And you're probably not doing, they probably don't ask you math questions. Uh, whatever it is, John, I think you can do it. It's a math program. Oh, okay. uh, agreed, Silverbird. Yeah. I'm just getting confused on how it happens simultaneously with the expected value for x or more. It's like that's number of ones. Like it'd be nice if we can just subtract them. I feel like that's not quite right though. I guess that's 11 minus x would be the hits. But I feel like just subtracting them like this isn't right. Sorry, we need an n there as well. So okay, so you're saying that is okay, Silverbird. That felt wrong to me. But I'm not that comfortable with probability. So and then I guess we would just equate them and solve for x if this is to be believed. Yeah, I have to create rigorous proofs to apply for this fashion brand. Yeah. Uh, we take that and add that. We get 4 over 10 is 2 over 5. Oh wait, the ends just divide out, don't they? Ooh. That's interesting. It doesn't depend on n. I felt like it would, but apparently 7. Uh, so I would want to back this up with like a simulation, but we've gotten an answer. It feels reasonable because the 1 out of 10 chance to subtract 1 doesn't happen that often, so I wasn't thinking it should be too far away from 8. Um, I'd be interested in trying to like see if I could code this up quickly. It might be a neat problem, but I want to take a look at Stoffel's problem first. But I think allegedly we have an answer here. Like in I'm not that confident with my probabilities, but Inbox. Ooh, that's a crazy substitution. I was just gonna do binomial expansion on that. I don't feel like there'd be that many terms. And the powers are gonna be kept under control by the cancellations between those. So x to the 6th I'm ignoring because it cancels. 6 choose 1 is 6. Uh, x to the 5 times 1 over x is x to the 4. 6 choose 2 is a number. 15. That'll be x to the 4th. I'm going to lose track of this so I don't write this out. So we're going to go by powers of 2 each time, I guess. He's way to test just ran with 5 dice as an example and got 1.5 as the output. Oh yeah, I guess we don't necessarily even have to code it. We could just do some dice rolls and see what pops out. So like 1.5 hits, or how do you get half a hit? You see the easy way? Ooh, a rare Fenbox curse. You know he means it. Not even the E and M problems would make Fenbox curse. You love to see it. What is the easy way? That was 6 choose 1, 6 choose 2. So need an F-bomb? Yeah, I love it. Divide my quadratic by x. Oh. Well, let me just squared minus 4x plus 1 equals 0. Divide it by x. Well, fuck. That is indeed a fuck moment. It's a I was gonna call it a fuckable moment, but you know what? I this is a fuckable moment. I'll say it. 4 to the 6 is 2 to the 12. 2 to the 12. 4096? 4096 plus 2 is 4098. Is there an easy way to reduce that though? Or that? Fuckable mass. Ignore the problem, hope it goes away. Yeah. Leave it as 4 to the 8? Or 4 to the 6? Come on. Really? Oh, come on. You can't do powers of 2. That's some weenie math, but okay. This is much less fuckable, I would say. So I want to rate all of math now, how fuckable it is. You always leave excellence until absolutely necessary. Yeah, it might simplify, you're right. um Oh, I don't like the negatives they give me. Yeah. Negatives are not very fuckable. Honey Daffy Duck, thank you for the follow. Hey Jesu. Um okay, I see what you're saying. I'll read that in a second. Lycan, just as an average, if I take 5 dice and roll them to game 1 standards, you get 30% of that, so 1.5 hits on average. Same mass for 10 yields 3 hits. Oh, okay. I run the sim I already have the second system. Same dies, it feels incredibly simple, x equals 7. Okay. Awesome. I mean, at least for me, it's not simple, but there might be there might I guess this is the simple way. I just probabilities are always so tricky with what you're allowed to do that I never feel quite confident. Okay, so me talking about Papadoria's problem from earlier. At the top of the page there. If your equations are right, then it's possible to solve it with a linear equation. 1 over b minus 1 over a equals 1 over c minus 1 over b. 2 over b. Ooh. I don't know if you hear Papadoria, but I'm still not sure how we deal with that, but I do want to write out what Amit is saying here. Geometric sequence. I'll type Papadoria's name in the YouTube chat. So, Amit is saying 1 over b minus 1 over a is 1 over c minus 1 over b, just by the definition of an arithmetic sequence. That implies 2 over b is equal to a plus c over AC. Okay, yeah, sure. If you add that to their side, add the 1 over a to their side and get a common denominator. I agree with that. 2AC. Okay, yeah. 2AC is equal to AB plus BC. It's cross multiplying. A times 2C. Oops, not equal. Plus B times minus C is equal to AB. Which implies the GCD of AB is equal to AB, which is greater than 1 by the construction of the problem. Okay, yeah, so I agree with Ben Blocks. I'm trying to justify that implication. You're saying it's by the linear combination. Isn't the C messing up that linear combination idea? Like, I feel like we should have to divide the C over. Or wait. How is the greatest common divisor of A, B, A times B? Wouldn't that be least common multiple? Or like, if that? So the simplest example is A equals 2, B equals 3, C equals 6. The GCD of 2 and 3 is not 6. Wait, isn't the GCD... Wait. But that doesn't... Wait, that breaks the problem, though. Did I write this wrong? Six, 3, 2. Oh yeah, it has to be increasing. 6, 3, 2. But the GCD of... Okay, but the GCD of 6 and 3 is definitely not 18. Like, shouldn't it just be 3? Right, I had your question answered. You did the second... Oh, yeah, to be honest, I've been skipping around a lot. Shoot, I guess let's solve this question. I guess we maybe found the hardest part. I still don't quite know what to do with these high powers here. Maybe that's not the hardest part. Factor the numerator? I don't see how, but turns out I read the real system incorrectly. Oh no. I don't know. So like the original question was simplify this given this is true. And Fenlux spotted this amazing implication from the quadratic that really helped us out here. That gets us that. But then I still don't quite know what to do with that. Oh, Saito, so you're saying that piece factors, ignoring the -4 to the 6? Uh, polynomial division? Does that work with negative powers like that? I guess you could get rid of the negative powers. Squaring or cubing it. So I don't. Sorry, I'm saying this to try and take stock of what we have left to work on. Yeah, like, and I guess we can come back to your question once we make a bit more progress on these. I'm not sure I completely buy Amit's argument here. It would be really nice, but I still have trouble with that last implication there. Like even the claim that GCD of AB is A times B. That doesn't just doesn't seem right. So let's make a bit more, and I'm gonna put a pin back in this problem unless we hear a response. Let's make some progress on Soffel's problem, and then we come back around to Lycan. Okay. Ooh, Lubird. So Lubird is noticing x cubed plus 1 over x cubed squared is x to the 6 plus 1 over x to the 6 plus 2. And that matches with 3 of those terms. So x cubed plus 1 over x cubed minus 4 to the 6. Oh, so Soffel was right not to simplify the 4 to the 6. Okay. And then, yeah, that's a difference of squares. I guess I don't need those parentheses, do I? And then the magic of this is that those two cancel entirely. It's still a little stupid. I guess you could. It's in a way better stage now if you want to try to plug in the root, or one or both of the roots. You don't need to plug them in? Oh, okay. Is that good enough for a final answer then? It can still be simplified? I mean, you can get a common denominator. Is that simpler though? It would seem like, wait, you want me to square that? Square, oh, square this. Oh, to get a simpler, okay. You got the original expression in terms of x plus 1 over x. Oh, were you just like factoring it around, or? True crime and body cam? No, I definitely do not. Like having that sounds stressful to have in the background. Oh, I see what you're saying. So in plus 1 over x squared equals 2. And then we're going to take this equation and multiply each side by that equation. Okay. Two times 4 is 8. That is sneaky and beaky. Wait, why am I not getting cubes? Oh, because I don't know how to write. Eight. Okay, so then x cubed plus 1 over x cubed equals 8 minus x minus 1 over x, allegedly. 16, not 4. I forgot to square it, yeah. Thank you. Then goes down to 14. And then 14. 14 times 4 is 28 times 2 is 56. That is saying it's 116? I'm not sure. There's not to do something stupid. Oh. I guess so. I don't know. It's watch people dying so you can be immortal? Is that how that works? You like absorb their life essence through the monitor? Okay, so that's a lot. Oh, and then we use the fact that 56 minus 4 plus 4 cubed. I was so you never use the roots. That makes life a lot better. 4 cubed is 2 to the 6. 2 to the 6. 64. 64 plus 56 is 120. Minus 4 is 116. So I agree with you, Cytos. You use the roots? Oh no. Okay, so Lycan, if you want to post the second part of your question, I think it's a good time. What a sneaky problem. Hence my F-bombing. I was literally just gonna do binomial expansion on the top and bottom and assume that we get something that's not unbearable. I'm still thinking about Amit's idea in the back of my head. Like, I think you could say this is true, but we have to say AB over C is an integer, which I don't know how you show that. But anyway, we're talking about Lycan's part 2. You know, let me put this old work down below so we can read the entire situation at once. Oh, well, you go up there. Come back for you later. You go down here. Okay. Reading the first edition book, I'm not going to completely clippers for the old rules. Everything mentioned before still is true. For game one, if you roll a 10, it explodes. You take that die and roll again. Ooh. Only in game one. Okay. Uh, okay, so is this the same thing as just we never get 10 and we only have 9 real possibilities? Because I think that's a pretty small modification. If we can say it's that simple. So we'd only have 2 good results out of 9 total. Yeah, I feel like this setup should be the same thing as just rolling a 9-sided die. I feel like that's not unreasonable. So I hope that's not unreasonable. Um, so we would have, oop, not 9. 2 out of 9. H2 is the exact same. We do get harder fraction math now. That's unfortunate. Um, let's just do this problem differently. Uh, that's 11 minus x minus 1. So 10 minus x over 10. Okay, yeah. I think I did that math okay. So negative 70 is negative 9x. We're going to get a fraction here. Oh, really, Lycan? Oh, I misunderstood then. Okay. I see, you did say another hit. So you get a hit and then a chance at another hit. And that's going to make this probability very tricky, I think. So I think we need to think about what happens just if n equals 1 to try to get a handle on this. Um, so um, we would be happy with a 2 out of 10 chance if we get an 8 or 9. Or we'd be happy with the 1 out of 10 chance that we get a 10. But then once we're in this universe, um, we get more things. Yeah, exactly. Because you can theoretically get infinitely many tens. Or, as many tens as you're willing to roll. Cytos. Oh, this is your full work, I guess, for that problem. Oh, interesting. Oh wait, that does seem a lot easier. What the hell? Okay, that's a pretty good solution too. Enduring? I'd never heard of it, no. Who's it by? Me say here's a DM watching my players keep rolling the same die for 4 hours. Are you gonna stop rolling a 10 yet? Yeah. So Geoplex? Let me during Geoplex. Add to queue. This is the song. We can probably cut it off after like if we don't if you don't care about getting the exact answer, we could just kind of cut it off after a couple of these and call it good. But um so once we've gotten 1 out of 10, we could also we can then roll again and we have the same 2 in 10 chance for an 8 or 9, or another 1 in 10 chance. I think this is how we're nesting. I feel like there should be some way of simplifying that, even if it's infinite. This song is okay. It's kind of like epic. Oh, sorry, these are probabilities, I guess. Um oh wait, oh no, I'm sorry. You're talking about something else. You don't need to be exact. There's a lot of have to be rounded. Yeah, right. You have to choose a whole number x. So we have 2/10 from here. The next term, like the only thing we have over 100 is 2/100 from these two multiplied. We should write this as powers of 10. And then what do we get next? 1/10 times 1/10 times 2/10. 10 cubed? 1, 2, 3, yeah. Oh. Okay. 1, 2, 3, 4. I think we got a pattern. This has a known sum. It's a geometric series. Um, what song did I mention? Oh, just that it sounds like kind of epic, like a Pirates of the Caribbean song almost, but obviously electronic music and not like whatever genre that is. Um, yeah, it is cool. How would we write that? N equals 1 to infinity. It's underrated? It's pretty good, yeah. Wait, do we need to start from 0? I forget. I think it's the same if you start from 1, or if you do this and start from 0. I'm going to start from 0 just in case, because I'm paranoid about this being wrong. I feel like it's fine either way, though. And it gets you the same result. But it's not that hard just to be sure by doing this. Okay, so then the formula for this is a divided by 1 minus r. Two over 10 divided by 1 minus 1 over 10, which is 2 over 10 minus 1, 2 over 9. I feel conned. uh... Wait. No. This isn't that. This is no. I didn't do this quite right. The number of hits is increasing. This isn't just one hit. Um, the issue is I was just trying to track the probability, but that's actually not the most helpful thing to do here. We need to think about the chance of getting one hit is, well, if we get one hit, then we either got an 8 or a 9, or a 10 followed by a not hit. Those are the only scenarios where we get one hit. If we get two hits, we'll get into cases very quickly. Oh, did you code this up, Supple? Wait for me to solve it? Oh. This is getting more complicated than I thought it would, to be honest. I mean, I could try to keep on doing this, but I'm losing faith in this being good. Oh, I mean, it could be 8. I'm not sure. So we could get an 8 or a 9 and an 8 or a 9. We could get an 8 or a 9, a 10, and then a not 8 or 9 or 10. Or we could get... Wait, what am I saying? No, 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 no. I'm doing this terribly. If we have 2 hits from one die, that's a 1 in 10 chance for the 10 times a 2 in 10 chance for 8 and 9, or a 10 on the first roll times another 10 times a not 10 and not 8 or 9. We have 3 hits. We have 2 10s in a row. And then an 8 or a 9, or a 10 and a not hit. Feels like a pattern is coming out of this. If x is the number of hits from one die, then e of x is 2 over 10 times 1. Wait. Times 1 I'm confused by, but I'll write it. Plus 1/10 times e of x plus 1. Die must not be good. Die in this context is just one dice. And like a dice is like the 6-sided thing that you roll. Get a 1, 2, 3, 4, 5, or 6. Cool music. Yeah, I mean, I've used this playlist before. I haven't used it in a minute though. Oh, is it too loud? I did turn it up and forget to turn it back down. Turn it down just a tiny bit. Um, so, okay, the 2 over 10 is an 8 or a 9. The 1 over 10 is a 10. But then what is this e of x plus 1? Because this would be really simple to just isolate e of x and solve it, right? What do you expect from your future rolls? Oh. Well, that's simple, isn't it? And, like, I assume we could just isolate e of x here? With normal algebra. A third? That's a neat way of thinking about it. Just defining e of x in terms of itself. And so for n many dice, I think you can just safely multiply by n. and do the same procedure. Thank you for that, Lubert. It's another sneaky problem. Third is 10 minus x over 10. Ten is 30 minus 3x. Negative 20 is minus 3x. 20 over 3. 6 point something? 6 and 2/3. So I guess x equals 7 still, funny enough. Well, no, I guess it depends if you... No, it's not possible to get it perfectly then. But I guess it's a little bit closer to 7. Close to x equals 6 in the Python? Okay. I'm kind of disappointed. Like I thought that infinite like nesting thing I had going was kind of a neat problem on its own to figure out what's happening. I'm annoyed that it didn't turn out to be useful, but nice. We got there in the end. You gotta go? All right, supple. Well, thank you for the question and thank you for the help on lichens. That with infinite sums. Yeah, it's a little bit harder than I was thinking though, because you have to track. I wasn't tracking the number of hits. Was the issue, I think. I guess I didn't see how to resolve that. In game one, you have the beneficial effect of exploding tens. In game two, you have the detrimental effects. Yeah, I guess the exploding tens only helps you. Or it only can help. Can't hurt. So that makes the... So I think it makes sense that we're getting a smaller x than without the exploding tens. Right? Because they're kind of... Game one just got a lot more attractive. You agree? Okay. Yeah, okay. So that makes intuitive sense, I guess. Oh, Papadoria. So I added you because Amit in the Twitch chat had an idea for your problem. I'm not sure that after I looked at it more, I don't think I ended up agreeing with it, but I'll show you what it was. And like, thank you for the question. Let me know if you want to like, so you remember both things, you might just force some results of both and graph them. Yeah, I mean, that'd be cool to see if you feel like posting it. Once you do. Of course, you don't have to, but it's always nice to like confirm this with actual numerical results. So Papadoria, there was let me drag this down. Amit had this line of logic to suggest. music feels a little bit loud, at least in my ears. Okay. Oh, I missed your message? I don't really, I can still see. Oh, I did miss your message. You have to go. Okay. Well, that's my bad. I didn't really see. I saw your last message, but I didn't see the one before it. Okay. Thank you for letting me know, Femboss, because it does show up differently in my ears than others. I think it's just a loud song. Maybe. Okay. Sorry, yeah, I did miss that. That's my bad. Um, but yeah, this line of logic was suggested as a solution. I'm not sure I agree with it, but I only don't agree with the last part. You can start with this statement, just from the fact that it's an arithmetic progression, and then you can rearrange it basically to get to this equation. And now Amit's claim was that this implies the GCD of A and B is the right-hand side of AB by the linear combination thing. Like the GCD of A and B can be written as AX plus BY. But I think there's a flaw in the logic that it has to be like the smallest X and Y, and if you can, like, I think that C poses a problem. Um, so I think, so I put it on this down here, where if you divide out the C, then maybe there's something here. Hey Mega, the notorious GCD? Oh my god. That would be such a funny, like, rap name. But I guess you'd have to prove this thing is an integer. But if you can, then I think you could say the GCD is AB over C, and that's... Hmm. Is that right? I'm checking it against this example here, and I think it's not checking out. 12 minus 3 is 18 over 2? Oh, that checks out. The GCD of 6 and 3 is 3. Um, but AB over C is not 3. What the hell? Hey, Vivan, how's it going? I did get to 1,000. Thank you. Why is this not the GCD of A and B? So this formula works with these numbers here, but it does not work with this formula here if you made it over C. And that seems weird, right? I thought from here you can properly apply this GCD thing. Evidently not. Can I make myself some room? But yeah, so that's where we got stuck. I never heard of me come back with a rebuttal. So I kind of just like left it alone. Or anyone else come back with a rebuttal. Hey, Sally. Pretty good. How about you? If you go web scraper, ooh, nice. I'd never written anything in Go. So yeah, I guess that's only the update for your Papadori. I'm still not sure like what to do with this. It's nearly really good, but I mean, I guess you still need to prove that AB over C is more than one. No, there's something wrong here. Oh, nor is it at all a meet. Only do it if you feel like it and you're interested. Please like don't feel obligated to or don't feel like you have to. It's your third Go project. Oh, nice, nice. Yeah, yeah. This is something to something to chew on. I did just realize that at the start of the stream, I was working on the Solid Revolution stuff, and I completely left it alone. Unless someone has a question to ask, I'm gonna go back to this maybe. Or if there's a breakthrough in Papadoria's. But the person who asked this in Discord, I do want to respond to them for the end of the stream. This was a neat induction. I feel like I've seen it before the more that I think about it. Oh, I haven't seen that one, Mega. So Mega is saying this is apparently true. Oh, in this problem. Okay. Moving C using the inequality AP greater than GP greater than HP. Oh, really? Or like, I assume like with the means, the arithmetic mean is greater than geometric mean greater than harmonic. Hmm. Or I might also be misunderstanding you and me. Some pizza, nice, famished. Okay, hacking away at this solve the revolution. 4e to the x plus 15x 0 to ln 6. A plus c over 2 is greater than or equal to 2 over b. Oh, okay. So yeah, that's something I wouldn't have guessed. Thank you for like spelling that out. E to the 2 ln 6 is 6 squared. Uh, I mean, since now I should. Okay, Awesome, like him. Hey, caller. Revisit previous talks now I went through. Reviewing every 2 weeks. You also want to change your notes digitally. Yeah, yeah. It's really good to revisit things that you just learned. Okay, I think I'm gonna use the bathroom. The urge just hit me. Um, I'll leave up the Papadoria question in case someone wants to think about it more. I'm just kind of putting a pin in it for now, but I'll just leave that as a screen while I'm gone. Okay. Don does P, I sure do. Some talks you need to work on more, so it'll benefit you. Yeah. Okay. Amit has a new has new tech. So me is saying a plus c is greater than or equal to 2 over b. So a plus c over, oops. A plus c is greater than or equal to 4 over b. Oh, wait. Yeah. Which implies GCD of AC greater than or equal to 4 over b. So, in doing this step, no, this can't be right. Um, are you saying a plus c is less than or equal to the GCD? I think the opposite is true. It would be nice. Um, oh man, if we can make something like this work though, this definitely would go really nice with Megalomorph's property. Because you could multiply the b over to the other side. I think you made a small mistake. Oh, okay. Like, I definitely do not agree with this implication arrow. But if we could get something like this, that could be cool. You do have that C GCD AB is equal to A. Okay. Yes, sounds good. Okay. So then since we're at a resting point with that just for a minute, I'm gonna chop away at this arithmetic here. Oh, cool, you got it. Yeah, I did that. Okay, so you start with that. Get rid of all the denominators. Almost done. Good luck, Stelly. Hey, user. User 5689. What's the question? No worries, me. Thank you so much for even like trying with that problem. Um, yeah, if anything, it's early for you now, right? um, yeah. Whatever you do next, whether it's sleeping or doing something else, I hope it goes well. It's in Spanish. That's okay. I can put it through Google Translate, or I might be able to figure out what it says on my own. Yeah, Salvador, I'm not sure how to use that either. I'm very inexperienced with it. APGP, HP. Oh, okay. I'm still having trouble justifying that step to that step. Oh, it's a general fact about GCDs. Oh, okay, okay, okay. You resolved it? Okay, sounds good. Then user. And yeah, Powder, I guess they're separate steps. Okay, so then what do you do then? You'd say a BC is 2AC minus AB. Sure. Uh, oh, and since they both contain A. Oh no, use the property that I had written. Um, like you can factor the A out, and then I think you're using like a few properties in that step, right? Like you're doing. Actually, I can just write down the Excalibur. You're doing the GCD of AB and AC is equal to the GCD of B and C first. To get rid of the A's. And yeah, the other one comes from simplifying GCD of CB is equal to GCD C minus B. You do that twice, I guess. Okay. And then the minus sign, yeah, okay, that is irrelevant for the GCD. Nice. So then you get, I guess, C times the GCD of AB is equal to A times the GCD of CB. Okay. The GCD of AB is 1. Which might take some justification, but it would give us that property. Well, No, the task from the problem is to prove the GCD of AB is more than 1, though. Oh, you're going for a contradiction. That's why. Okay. Okay, I see. The result, 6 and 2/3. I think we're just saying round up to 7. If C is GCD AB, or if C GCD AB is equal to A GCD CB, does that mean A is multiple of C, or could it just be totally stupid? Oh yeah, I am. Okay. Because I'm not sure, but I do see. Yeah, this does give us something to like that's kind of a nice idea of going for a contradiction if you let their GCD be 1. Can we find something wrong with this? Because we also know C is less than A, right? By the construction of the problem. Isn't that it right there? Yeah, I feel like C has to be less than A. In order for it to be an increasing arithmetic sequence. Damn. Yeah, Megamorph, you basically just did it. Nice. Yeah, nicely done. Uh, Papadoria applauds your solution, Megalomorph. I'll get the entire thing on screen in case you want to like get a screenshot of it or something. But nicely done. And that's only part 1. There's an entire part 2 here. Yeah. So you get paid the big bucks. Yeah, super elegant. Okay. Megalobucks. What's the good news, like in? I guess let's think about B then. Let's get cocky. Um, we could have A equals 4, B equals 2, C equals 1. That would be a geometric sequence multiplying by 2 each time. Just looking for a simple example that we can check things with. I need like a clapping emote. I feel like that'd be appropriate both for Megalomorph's solution there and Fembox's solution for the other one. Also an oh fuck emote. Can you even have curse words? I doubt you can. But what is the biggest case such that the GCD of A be greater than K? Where K is part of the natural numbers. The biggest case such that the GCD of AB is greater than K. Megalomorph? Megalomorph. How big can it be? Okay, yeah, I was trying to figure out like what that actually means. That's a nice way of saying it. Oh no, Lucas, this is just a simple example so we can check things with. This is not the answer. Took some brute force tests of game 2 with variable values of x, notice a linear pattern. See linearly interpolated with probabilities where x equals 6 and 2/3. It hit dead on. Hell yeah. Oh, I love to hear it like him. Instead of proving must be bigger than 1, we must find that bound. Different numbers. So it just means that you can't have like any repeats. You can't do like 2 and 2 and 4 or all twos or whatever. Um, an arithmetic sequence is a sequence of numbers that go up by the same amount each time. So like 1, 3, 5. That's a bad example. That's a potentially confusing example. Let's say 1, 4, 7, 10, 13. You're adding by 3 each time. That's an arithmetic sequence. Or it doesn't have to be 3, it could be any number. But that's an example of one. GCD. Oh my gosh. Let me just type that out. GCD, it's an acronym for greatest common divisor, and the greatest common divisor is like the GCD of 12 and 8 is 4. 4 is the greatest number that goes into 8 and 12. Just learning some English, yeah. How big can the GCD of A and B be if they're now a geometric sequence? Um, does the notion of GCD and LCM exist in the complex domain? I doubt it. Although someone else, I don't know for myself offhand. They don't really exist even in the real numbers, to be honest, right? So I'd assume not, but maybe some crazy person out there has made it work. How can a divisor be bigger than one of the numbers? It can't. Like, it can never be 13 in the example that I made up here. If you're working in the Gaussian integers, you get a multiplication by a power of I. Or you get it up to multiplication by a power of I. Are Gaussian integers like complex integers? I haven't heard that. Or like, like basically like complex numbers with integer a and b. In any unique factorization domain, you get GCD and LCM up to a unit. So Papadori, I guess the answer is yes, to my surprise. As long as they're integers, like but it may be off by a multiple of I. Where do I even put I when compared to 0? That's a funny question. Like, I'm interpreting you as distance, but I don't know if that's what you mean. We often graph complex numbers on what's called the real and imaginary, like, axes. And so this is just like a normal x and y plane, where if you wanted to graph, say, 2 plus I, you would go 2 over on the real and 1 up on the imaginary and say that you're right there. So if you wanted to graph just I, you would go right there, just 1 up on the imaginary. And you can see like geometrically or like visually, it's just a distance of 1. And if you think about it in terms of distance, it's the same as just the real one, as -1, and as negative I. There's a whole like set of points. Shouldn't I put in the z-axis? No. Or at least you could add another axis if you want, but you'd have to be careful about what that axis is and how you're using it, I guess. Positives right to 0, negatives left to 0, imaginary. Oh, kinda. I feel like you're making it three-dimensional when it's not. Like, we only have kick the shit out of it. Like, this is your x and y plane, and you don't usually add a third axis without some reason. Basically, like, the first number is your x, the second number is your y. And so the first number is your left or right of 0. The second number is your up or down from 0. A third axis for depth, I don't know exactly what you would want to measure with your third axis. I'm sure there's many things that people use that I just haven't heard of. But it would be something that I haven't really seen before for myself, at least. See, okay, that's a good question. If you have f of x equals to ix plus 3, With great difficulty, basically. So that's where you, I guess, yeah, that could be your third axis. I think if there's a complex function, they normally would represent it with like a heat map or something, or like they would do. They wouldn't add a third axis, but they would add like some type of coloring or something to show kind of trends. As far as I know, it's just kind of difficult to graph these functions, though. It's not clean. Oh, nice. So for the geometric, megalomorph can get that. Search up complex log. Oh, yeah, yeah. Nice. Yeah, that's a good suggestion, Papadoria. Okay, so if you let me actually back up. Lucas, if instead of the function you suggested, let's just do I mean ln of x, but x is a complex number. Actually, we often use z, but x is fine too, but usually z we use for complex numbers. And so you can define the logarithm of a complex number. It's nearly the same thing as a real. And the graph you get of this, there's a couple of different ways. That's a funny graph. What the hell? The hue of the color is used to show the argument. The brightness of the color is used to show the modulus. That would take a lot of getting used to read this. But yeah, this is a good example of they keep it two-dimensional, still real axis and imaginary axis. But use coloring to represent the values. Got to run though? All right. Well, thank you so much for the help with that, Mega. Have a good Saturday. What is the minus root of minus I? That's root minus minus 1, so 1. If you want to do weird powers like that, like the minus root minus I. Hey, Kamji? I did. I have a bachelor's in applied math. Welcome in. What is negative I? Is it root 1 or minus root minus 1? Wait. The root of minus I assume is equal to the root of minus 1 times the root of I. I hope that's valid to do. Well, no, you saw... no. How I usually deal with something weird like this is any complex number like 2 plus I can be written as some number r times e to the power of I times some other number we call theta. This is called the exponential form or polar form of a complex number. And this is a lot easier to take powers of. And so I just know that minus I is equal to e to the I 3 pi over 2. And the square root is like an exponent of 1/2. So it comes out to be e to the I 3 pi over 4. And then using Euler's identity, we can say this equal to cosine 3 pi over 4 plus I sine 3 pi over 4, which is unit circle, which is minus root 2 over 2 plus I root 2 over 2. And I don't expect you to get this because I did a bunch of things that you probably haven't seen before. But I'm just trying to say that if you start trying to take weird powers of complex numbers, you have to do a bit of work. It's not as direct as you're trying to make it, I don't think. Oh, and yeah, Finish. OpenStax is a really good set of textbooks, like all the way up to calculus. But even like they have textbooks starting like basically from scratch with math all the way up to calculus, and they have textbooks for non-math things too. So there is a procedure, Lucas, for dealing with these powers, but it's not. It takes it's not too hard, but it does take some practice. And yeah, Piggy Master was talking about whether there's any that I use, like where does any exist. Mr. Suited Coder, thank you for the follow. Oh, sorry, I was thinking for minus I. Minus 1 we can do a similar way, but oh, that's why you're asking about that. Because you were thinking about it's like root minus. Yeah, this is like there's not a whole ton you can do with that. Besides putting the form that I put over there. Um this would be a whole lesson if you really want to like learn it. Like it will be pretty involved. No, it's not. Like this minus sign has to stay here. It cannot go there. What you do is you would say that this is equal to that over there and do the work that I just did. And so there's a few different things in the complex number line you'd have to learn to understand this, but the first is that if you have a number like 2 plus I, that you can write it in a polar form, which for this particular number will be e root 3 e I arctan half. And then you could translate that into cosines and sines. So there's two different things that, like, kind of significant things to understand there. Jamie Collis, welcome in. Looking to learn and study up on math using the Brilliant app, which has been so fun so far. We mentioned some books when I joined that are good for up to calculus. Oh yeah. Welcome in, Jamie. So we were talking about OpenStax. They're really just free textbooks online. And so if you dive into the math section, algebra, trig, calculus, college algebra, contemporary math, developmental math, pre-calc, data science, stats. Like, these are all textbooks. Yeah, and they have a lot of subjects here. So if you want to get started in learning something, it's not a bad place to start. If you're going to go through them all, that's an undertaking. Minus root minus 1 is minus I. So minus I is minus root minus 1. So minus 1 root minus 1. What the hell? I'm losing the thread halfway through your line of logic there, Lucas. um, and keep in mind, Lucas is just in a pre-calc here, so a super advanced explanation isn't going to help. Or like, it's not like it's not the most helpful like thing to give here. I imagine there's some property of exponents that are being weird, Lucas, but I'm not following your logic to be honest. I studied computer science and have some foundation in math, so a decent part is just revision and relearning. Oh, nice, nice. Yeah, just because I see you're here and you're a new face, and there's been a few new people today, I do like to let people know that I'm not the only person who streams math on Twitch. So if you ever have a math question, and both myself and each of the two I Pi do some coding stuff as well. This is a niche that exists on Twitch. So yeah, if you have a question, feel free to ask, or if you're welcome to hang out too. Web scraper finding dead links within the given domain is finally done. Nice, Stelly. View pre-algebra. Oh yeah, yeah. 3 is the root 3 squared. Yeah. By the way, I'm probably gonna stop working on 1B from Papadoria because I don't know where to go with it after that, but color code, I don't think that's gonna make a lot of sense to Lucas. That's like the really like, or that's using a lot of symbols I don't think Lucas knows. Um, so 3 is root 3 squared. Yeah, it is like NZ and Q there. And going back to your original comment, minus root minus 1 is minus I. So minus 1 times root minus 1, sure. Oh, root minus 1 squared. times root minus 1. Are you saying this equals 1? Because then you get root 1 times root minus 1. That doesn't seem right. It's not concurrent. Okay, fair enough. To us, Lucas, I probably wouldn't worry about everything. I'm sure that the color's right, but it's probably more complicated an explanation than you need, or then you're probably like wanting, I guess. Say root minus 1 squared is root minus 1. I don't think you can. Root minus 1 squared is root minus 1? That's just not right. Um, all right, I guess I'll let you go back and forth with color code if you want, but I think you're just doing some bad math along the way there, Lucas. Um, so yeah, the Papadora question, I think I need to just give a rest. I really want to get through the solve of revolution question. You know what? I should actually just Wolfram this, to be honest. I'm getting towards the end of my energy levels now. 0, 6. $35.347. Okay, so I agree with number 2. Freaking OBS. Okay, what was number 3? Perpendicular to the y-axis. So if we have y equals a half e to the x plus 2, I want to solve that for x. 2y minus 4. So then x equals ln 2y minus 4. And then y is going from 0 to whatever the x value is when y equals 5, ln 6. No. Wait, why is it just going from 0 to 5? Why am I making this more complicated? No, y doesn't go from 0 to 5. Oh my god, bro. Y goes... Wait, I'm thinking about this wrong. Do we need to do this in y? Perpendicular to the y-axis. I think we do need to do this with y. Yeah. Okay, so y is going from whatever this point is up to 5. That point is x equals 0, just 3 over 2. Okay. And so that's a semicircle, the area of which is a half pi r squared. No. Ugh. Rafa's gonna do this to me. ln 2y minus 4. That's not good. It's 5 over 2. So why did the Viking have a 1/2 there? Ooh, wait. Am I thinking about this right? I think I'm making semicircles that go like that. But we need to make semicircles that go like this. No. Yeah. So I'm not doing that right. Garrison posted. Ooh, okay. Too smart to be called Piggy Master. So the expected hits. Versus choices of X. Trying to match the diamond marked line. Okay, yeah, so that dark blue one. Oh, and this is the thing that you interpolated. Because x equals 6 is here, x equals 7 is here. And this is 2/3 of the way to 7. Nice. I love to see when calculations come out right like that, or like seeing them confirmed. My brother's account, I'm about to change it. Sobriquet? Sobriquet? That's a new word. Oops. Sobriquet. Cat. A person's nickname. Ooh, you taught me a new word. Sobriquet. Okay. It's a fancy word. Thank you for following up with that graph. Like him. Bruh. It's a cool word. I like it. I see you posted the actual data too. Nice. Okay, C is kind of actually challenging. We need to know where to cut it in half. Or like not, is it in half? Yeah, I guess it's in half. Square is another one I did just for fun, based on the system as described in the 5th edition of the book. Each pair of tens rolls. Each pair of tens rolled adds 2 extras instead of exploding. Oh, okay. Nice. Depends at all. Foreigners who learn English often know more fancy words. Oh no, I agree with you. No offense taken there. There's a lot of people who speak English as a second language who speak it better than Americans do. It's in my experience, so. Okay, so think I think if we want the semicircles to be like that, we need to stick a 1/2 in front here, and that's our radius. Because if you just use this thing straight up, it'll make semicircles like that. So I've never heard the word sobriquet in my life. Um, uh, is this the word I'm thinking of? No. There's a similar word that I guess like pseudonym or nickname or something is what people would be more likely to say. You might need to do more crosswords. I don't know if you've ever seen sobriquet show up in a puzzle. Hmm. A lot of my vocabulary I got by reading a lot as a kid. But it also makes for a lot of words that I'm not quite. I've seen them used, so I have half an idea of what they mean, but I don't quite know. Okay, let me I want to get a response to Viking. I'm going to include a couple of screenshots here. First thing, at least my experience learning English was from age 5 to 16. So from watching pirated English movies back home with the subtitles on. It works, it works. Wait, no, I'm gonna say every single letter. Okay. A. Thank you for the follow. Um, yeah, so what I'm doing right now is I'm typing out a response to someone who asked a question in my Discord about salt of revolution. Well, I guess part A is about finding the area bound between that function and y equals 5. Part B is doing a salt of revolution around y equals 6. Part C is finding, it's really weird. Um, finding the volume of a solid with like the base given by the region. I think I figured it out. How come one person dance, 80 people dance, whatever that is, dance, but he dances? Is he dancing more than me? Is he dancing? Oh, he dances. Yeah, the conjugation. I never thought about that. I love that. That's so funny. Dances rather than dance. I dance, but he dances. But people dance. I don't. I don't even know how to like express those rules. It's a great stand-up joke. yeah, it's just the only thing I was debating is if we want to where we should put the one half. Like if you put the one half there or the one half there. I think I've done it right. Putting it by the x. Was it ln 2i minus 4? Basically the radius of the semicircle. Hey, Ollie is human. Welcome in. How's it going? Yeah, that's a really tricky one. Setting some stats, nice. I'm just responding to this person about their calculus question. Posted to the Discord. Um, then I'm not sure. Okay. I guess we gotten. Hope we got in the bottom of that question. Uh, the geometric sequence one. I feel like I'm not gonna be able to do that. Okay, I guess we got to the bottom of the questions that people were asking. Um, yeah, I'm sorry, Papadoria. I just feel like I would need Mega to carry me through this, and he had to leave. Like the contradiction was such a nice strategy. Professor Perde, hopefully. So yeah, I'm really not sure like what to do with it. The sequence in general, I guess, but yeah, yeah, it's always like the reciprocals. So like, if this is your choice of A, B, and C, progression is 1/4, 1/2, 1. And so Megalomorph, we solved part A, found this probably helpful fact about part B. But I'm really crappy at these questions, so now that I'm on my own, I don't know what to do with it. Yeah, I guess since there's a moment and there's a few more new people around, whenever I see new faces, I do like to let them know that there's a math streamer niche here. I'm not the only one who streams math help or about math. And there's even more than who are on that list, but if anyone who's lurking or is chatting is interested in more like math streams, be aware that there's more than just me out there. It's a bonus question. Oh, good, good, good. It makes me feel better. Some like 3 days, you have some time to think about it. Okay. Um, Honestly, guys, I think I need to wrap things up though. I'm getting hungry and tired. I'm stalling for a little bit to see if someone pops in with a question, but I think since things are slow right now, anyway, it's a natural spot to end it. Yeah, I don't know my longest math stream is. Probably I bet I've gone for 6 hours or something, but I'm not sure. Yeah, no physics. I was planning to do physics, um, but today was such a busy day that I didn't have time. Um, I would do some right now, but I don't know. My stomach is growling. Yeah, Papadoria, thanks for the question. Um, I'll see ya. I'm kind of the YouTube stream up here, and then we'll look for a raid on Twitch. So goodbye, anyone on YouTube.